This is Group 2, More Problem-Solving Strategies. Lynn Stain says, what do humans do with the language of mathematics is described patterns. Patterns come in different forms and ways. You can put a pattern in a table to help you figure out what comes next. Hi, my name is Michaela. I will be talking about looking at patterns and making tables. Take a moment to figure out what comes next in the tables below. You might ask yourself, does it get larger? Is it smaller? Are each number's shapes or sizes related to the predictor? Do you recognize what goes next in the sequence? The first one, each number listed is greater than 5, then it's predictor. So the next 3 is 30, 35, 40. The second one are shapes that repeat. So the next 3 is a square, circle, and triangle. The third one is a sequence that appears just the squared numbers. The fourth one, we are starting with 1 and add any 2 terms to attain the next sequence. Next, Fibonacci sequence is a set of numbers that start with 1 or 0 followed by 1 and producing based on the numbers that each number Fibonacci number is equal to the sum of producing 2 numbers. Next, I'll be talking about making a table. There are 4 parts of making a table. Part 1, you will observe that the array of the dots are similar, but the array has 2 or more dots in a column. Part 2, you can count the dots in an array. In part 3 and 4, there are odd numbers, so we could write it out, the first million of odd numbers, but it's easier way to put it in a table. So overall, you look for a pattern of how to strategize a sequence. It can help you figure out what comes next in a table to show you how to figure out what comes next. Now turning it over to Jared.
Jared, you're muted.
Sorry about that. Have you ever paid attention to patterns in your life? It's okay if you don't, as I forget to notice it as well. At the same time, it's important to notice and observe the patterns that guide you through school and through your own life. For example, you have to take care of yourself and clean up daily, like brushing your teeth and putting on deodorant, taking showers to look presentable. In math, you use formulas such as PEMDAS to solve mathematical equations. Now that we are thinking about patterns, I want to look at a specific pattern known as Pascal's triangle. The story behind the creation of the triangle is very interesting and can help in explaining the importance of Pascal's triangle. On top of its history and significance in math, it can also be practically applied outside of the classroom. The triangle itself has actually existed as early as the 10th century and was reformed in the 13th and 16th centuries by the folks you see listed in the 4th section of the PowerPoint. But the modern triangle didn't come to fruition until the 17th century when it was developed by Blaise Pascal, who was a well-known scientist, philosopher, and mathematician. In mathematics, he was known for creating Pascal's theorem and Pascal line. This theory states that if a hexagon is inscribed in a circle, the three intersecting points of opposite sides lie on a singular line, which is known as Pascal's line. Now, what's the main idea of Pascal's triangle? It's to use the binomial array of numbers listed here on the chart to add new numbers and rows to the triangle that's listed below. These numbers represent the parts that make the triangle function. The way to build new rows is to add two numbers on the top row to create the new row. For example, look at the third row. You have 1, 2, and 1. The ones were created because they were alone on the sides, but when you add 1 and 1 together, you get 2 and have created a third row. You can subsequently create the fourth row by adding 1 and 2 to get 3 on the middle sides, and then adding your solo ones on the opposite ends. Now, the key here is to look for the paths, and you can usually figure it out. So how does this relate to patterns? Well, you can actually find the patterns in the triangle itself. Two examples are listed here for you. One of them is Fibonacci sequence. You can find it in the triangle by adding the diagonals of the numbers going from left to right. For example, if you add 1, 5, 4, 3, 1, 5, 6, and 1, you get 13. Subsequently, if you add 1, 4, and 3, you get 8. If you add 1, 3, and 1, you get 5. Those are all numbers that are part of Fibonacci sequence. You can also get powers of 2 out of the triangle by just simply adding the sums for each row. Like, for example, the second row, the sum is 2, which is 2 to the first power. The third row's sum is 4, which is 2 to the second power. The third row is 2 to the second power, and the fourth row is 2 to the third power. Now, why was it better that Pascal's triangle was used instead of just explaining these patterns on their own? Well, for me, it's because you can visualize it here in the triangle, which is so much easier for me to do than just try to think of the patterns themselves out of thin air. Now that we know what it can be used for in the classroom, how would you use it outside of the classroom? How would you use the triangle in the real world? To be honest, it's not easy, but it can be used most notably in calculating the probability of an event. This was actually discovered by Pascal himself with Pierre de Fermat when they were experimenting with the problem of points. It goes like this. If you're playing a coin tossing game with heads and tails, you stopped and player A has won 8 tosses and his heads, player B has won 7 tosses and his tails. You can actually calculate the remaining outcomes to determine who could win the game. And if you have to abruptly stop, you can just split the winnings between players A and B based on what the score is like. In this case, player A would win 11/16 of the pot, and player B would win 5/16 of the pot if it were something were up for grabs. And sometimes you don't have to solve a problem with it. You can just create something cool, like in the background picture, a Chinese-based company just created a museum exhibit off the triangle called Lost in Pascal's Triangle, where the triangle exhibit will play music and display flashing lights when visitors experiment with it. So as we discover today, Pascal's triangle is a very interesting concept. The fact that Pascal was able to discover the ways that we use the triangle today is very inspiring. And while it may seem tough to do, the triangle can also be used outside the classroom. And that wraps up today's lesson on Pascal's triangle. Thanks for paying attention, and make sure to be more observant of the patterns that you see yourself following. I will now pass it on to Jamie.
Thanks, Jared. So I'd like to start off with a question. Where's the only place you can buy 38 watermelons and no one wonders why? An elementary school classroom. I'm Jamie Huseman. Problem solving is a vital skill for anyone. At first, it can be daunting, but it only takes a little determination and a little knowledge. Have you ever asked yourself why problem solving is so important and how it can be applied to everyday life? Today, I hope to answer these questions for you. I'm excited to show you 2 problem-solving strategies so that we can turn your problems into solutions. So, how do you show a number that you don't know the value of? We can use a variable. A variable is a symbol that represents a number in which the value is unknown. Let's suppose I need to buy 38 watermelons for my annual back-to-school party. My total at the farmer's market is $152. How much does each watermelon cost? We have 38 watermelons, and my total is $152. We can use the variable W. We divide each side by 38, and we come up with the amount of watermelon. Amount per watermelon is $4. How would you find out the number of watermelons you can buy if you only had $20? We know that the watermelons cost $4, and we only have $20. We use the variable N to determine how many watermelons we can buy. We divide each side by 4 again and come up with the number of watermelons as 5 if we can buy if they cost $4 and we only have $20. Now let's say we have a more complex problem. We can consider special cases to consider our problem. So how do we rephrase the meaning of special cases? Applying a strategy you already know to a problem you need to find the answer for. Now let's suppose I need to figure out how many watermelons I need to buy for next year. We do need more information. So I bought 38 watermelons this year. I bought 32 in 2016, 35 in 2017, and 29 in 2015. So how many do I need for next year? We can determine that these numbers begin a pattern, proceeding up by 3. So the next number should go by 3 also. So we add 33 to 38, and we determine that in 2019, I need to buy 41 watermelons. What changes would you make to solve the number of watermelons if you increase the number by 3 each year? We added simple addition and subtraction to our variable to determine our answer. Now, how would you categorize that progression? That progression is a special case. What choice would you have made in solving these problems? There are different ways to solve problems. It is best to start with what you know. In conclusion, I hope that I have calmed your fear of problem solving and renewed your determination. You can now use variables and consider special cases with ease. I hope you take what you have learned today and apply it when you're purchasing watermelons or just pizza with your friends. Using a variable can be used in many situations. Likewise, using special cases is just applying what you already know to find your answer. We've covered 4 vocabulary words today, and they are as follows: variable, term, special cases, pattern, and progression. Thank you guys for watching, and have a great day.